Good morning, one and all. Today we will be discussing an important concept called fork, which is the base and starting concept for the program operating systems. As we all know, operating systems is a very important course for your placements. Not only placements, it is also a core concept for the students who are studying computer science systems. Now, let us start our class. In this tutorial, we will mainly discuss only about the concept of fork. What is fork? Why is it called as fork? And how is the fork function call used in the programming languages? How this fork function call is mainly related to the operating systems. Now, let us go into the topic. The fork system call is used for creating a process. Before going to the fork system call, we need to understand what is a process. Generally, when you go through some of the articles or PowerPoint presentations regarding operating systems, you would have come across some of the terms like process, fork system call, etc. You may be wondering what is a process. A process is nothing but a program in the running state is called as process. For example, you might have learned of some of the programming languages like C, C++, Java, and Python. And when for implementing the programs in this language, you mainly download an offline compiler or you go to an online compiler and write the code in your particular programming language. So when you write your program or code in the particular programming language and when you compile that particular code, your desired output will be generated and it will be shown in a separate console. Okay. So whenever you write a program and when you after completing the program you go and click on the run button, so this program will be running, means the compiler will check the syntax of the program and it will try to produce the output. So this particular program, when after clicking the run button, will go into the state of running state. So this particular whatever program you have written in the running state is called as process. Now, how can this process be controlled? With the help of the fork system call in C programming language mainly, we can control this process. The fork is a system call that is used for creating a new process in Linux and Unix systems. This particular fork system call will give you an error when you implement this in the C in the Windows operating system. Like generally when you open your laptop, go to the Google Chrome and type for fork and open an online compiler, include the fork system call in your program, and when you run, it will show you an error that the fork system call is undefined, which means that fork system call is only suitable for using in Linux and Unix operating systems. Now, fork system call is called as the child process, which concurrently runs with the processes that make the fork call parent process. After a new child process is created, both the process will execute the next instruction following the system call, which means that suppose in a particular snippet of C code, after the main in the main function, after a particular statement, if I write fork like fork function symbol and if I give a semicolon, which means that when the compiler starts running the code from first line, when it comes to the line which contains the statement of fork, immediately after executing the fork system call, there will be a two process created. One process is called as the parent process, and immediately one process is called as the child process. I am repeating, my dear friends, again. When the compiler starts compiling your code, when this particular control reaches the line containing the fork statement, it will execute the fork statement, as a result of which there will be two processes created. One is called as the parent process, another one is called as the child process. So as you can clearly see in the diagram, whenever the function call fork function call is executed, there is a parent process that is created, and there along with the parent process there is a child process that is created in the operating system. As you can see here, we have an sample C program where we have written here. You have included all the header files that are needed for running a sample C program. You have entered into the main function where you have written the fork call, and you have written printf hello world, which is a basic C program. Now the compiler will start its execution or syntax checking from the first line. It will check all the header files, correct? All the header files are included. Then it will come to the main function. Yes, main function is there. Now it will enter into the main function. Now we will be going into the fork function call. When the compiler executes the fork function call, immediately it will understand that it should create two new process. So immediately within the same program, two child and parent process will be created. As you can see, output of this will be two hello world, which means that there will be two times hello world printed. Now let us see the next example how the fork call is implemented. As you can see in this particular snippet of code, there are three fork function calls which are being taking place, which means that the fork function call is written three times. Then the compiler will interpret each of the function call at each of the function call. So as you can see, there are three times function calls written. As we all know that there will be two process mainly created for every fork function call. Yes, the number of times you can see the hello world is printed is 8. Now we will see how actually before we have discussed that once the fork is executed, only two processes are created, that are child process and parent process. But now you can see that for three function calls, 3 into 2 6, there should be only 6 hello world printing. But as here we came to see that there are 8 hello world. How, what happened? What is the main reason behind this? Let us see. There is an explanation given here. Is equal to the number of times hello is printed is equal to the number of process created. Total number of process is equal to 2 to the power n. This is a standard formula which we have to remember throughout the course of operating systems. The number of process created will be always equal to 2 to the power n, where n denotes the number of fork system calls. For example, in my program, I am having only one function call, one fork system call. The compiler will read this fork system call once, and it will generate 2 to the power n, means 2 to the power 1, which means that there will be two process created. Now as you can see here, my dear friends, there are three fork function calls, which means that the number of process will be 2 to the power 3, where 3 denotes the number of fork system calls that are present in your program. Please don't do mistake or forget this. N is equal to the number of fork system calls that is present in your program. Here you can clearly see that there are three function calls, three fork function calls present. So the number of process that will be generated is 2 to the power 3, which is equal to 8. So totally 8 process will be created. Now, the relationship between these processes can be clearly demonstrated like using a tree. Like, it is not mandatory to demonstrate, but generally for clear understanding purposes, we represent the output of this particular code along with a tree hierarchical structure, so that it would be still more clear like how the fork function call is being worked. Okay, now on moving to one more code snippet, let us see here how many fork. See, you have a sample C program where you have all the header files included. You have created a function void fork example, where in this function you are going to tell how the demonstration of fork will work. So now if fork function call is equal to 0, printf hello from child, or else print hello from patient, hello from parent, sorry, hello from parent. Now you are entering into the main function. You are calling the function that you have written outside the main function, and you are writing return 0 and closing the program. My dear friends, remember one thing. Whenever a fork function call is being called in the C programming language in your particular code snippet, the fork function call after generating will immediately return some value to the parent process. So, if that particular fork function call after executing returns a value of 0 to the parent process, definitely after create, suppose I have written 10 lines of code. For example, I will tell you in an easy way. Suppose I have written 10 lines of code. My In my fifth line I am having the fork statement, fork, open bracket, close parenthesis, semicolon. The compiler will come to the fifth line. The compiler will execute the fork system call. As we have studied earlier, for one execution of fork statement there will be two process created, 2 to the power n. Yes or no? According to the formula 2 to the power n, there will be two process created, which means that one is the parent process, one is the child process. Now these parent and child process will not have communication among themselves. So, what will happen is, for the parent to understand whether the child process is created or not, the child will return a particular value to the parent, so that, oh, the parent can understand, yes, child is being, my child is present, or my child is being created. So if the particular child which is created returns a value of 0 to the parent, which means that the parent can confirm, yes, the child is created, and it is a function, it is a value that is returned from my child. And further, if other than 0, if any positive value is returned, the parent will confirm that the child is not created, only the parent is existing. So upon further movement, we will study how communication can be established between the two parent and child. But as of now, limiting to the concept of fork, we will tell that this confirmation of existence of both parent and child will be taking place only with the help of returning of these values. Okay, understood, my dear students. Now these are some of the examples where you can go through in Geeks for Geeks website and practice some of the questions how this fork function call can be used. Now we can see we can see clearly see here what are the values that are returned by fork. Fork returns a negative value. I have already told you, to establish the communication between the parent and child in the very initial step, a negative value will be returned, which means that the creation of child process was unsuccessful. If the parent receives a negative value, which means that the creation was unsuccessful, so the parent can confirm that on execution of fork function call, child is not created, only parent is being created. If it returns 0, then it will happily confirm that my child is created. If it returns a positive value, the value contains the process ID of newly created child process. If it return instead of 0, if it returns a positive value, it may not be the child of that particular parent, but it may be some other child along with which it will send the process ID, so that to confirm that the child is being created, but it is not my child, it is someone's child, but successfully child process has been created. This is the this is how the fork concept is used. In my upcoming tutorials, I will still more clearly explain you the working of fork with some examples, and we will move on further in this operating system course. Thank you. Once again, thank you all my dear friends.